Hi, I'm George.
And I'm Chris.
We're with Aeroco. We're here to talk to you today about how to properly make a CADWELD exothermic connection. We're also going to show you a new product, CADWELD Plus. All right, Chris, is this all the stuff we need to make these CADWELD connections here today?
Yep, that's pretty much it, George. And it's pretty amazing when you think about it that using only a few lightweight pieces of equipment, we can go to a remote site and actually weld conductors together. It's pretty neat if you think about it.
Yes, it is.
There's no heavy hydraulic tools to keep track of. There's no dies to mess up. We don't even need electricity. Through the magic of applied chemistry, we're going to be able to make permanent electrical connections. So let's take a look at the components that we have sitting here on the truck. First thing that I want to talk about is safety.
Right.
There's only two pieces of safety equipment that Aeroco recommends that you use when making a CADWELD connection: safety glasses and gloves. Of course, common sense is also good to have. Your company may require you to have additional pieces of safety equipment such as a hard hat, or your job site may dictate additional pieces of safety equipment, but that's all that you need. That's all that we recommend.
Since we are here in this substation, maybe we should put our safety equipment on. I've got my glasses.
Right.
All right, Chris, I got the welding material out of the truck.
All right, thanks, George. Appreciate that. All right, now what we're going to do is we're going to take you through in more detail each one of the components used to make a CADWELD connection. Give you a little bit more background on how each one works, how they all fit together. It's pretty easy. First thing that we're going to talk about is the mold. Now, each mold comes packed in a box, and on the label of the box, there's some pretty important information, all the essential information that you need to know before you make your connection. The first thing that we want to point out is the part number. In this case, we're going to be making a PTC 2Q connection. We also have a description of the conductors that are being joined in the connection, along with a picture of the orientation of the connection. In this case, you can see that we have two cables being joined in a horizontal configuration. We also have the size weld metal that the connection requires. In this case, size number 200. CADWELD is what we call a pre-engineered system, meaning that in order to connect two 4-aught cables in this configuration, you're going to need 200 grams of weld metal. Anything less, you're not going to get a good connection. Anything more is overkill and you're paying too much. So let's open it up and see what we have on the inside. Now, the first thing that I want to point out is that each mold does come packed with instructions. And in fact, there's two sets of instructions that come with every mold. The first set of instructions, actually a pretty detailed description of mold setup, welding procedures, and safety precautions. We also have a pictorial representation of all the steps that are required to perform the CADWELD connection. So just know that they're there in case you need them. Moving on to the graphite mold. The mold tag on the mold basically has the same information that was on our box. We have the part number, a description of the conductors that are being connected, along with the weld metal size. If you ever need to get a hold of us, if you have a question about a mold, this is the basic information that we're going to require. Every mold comes packed with a mold clip that just keeps the two mold halves together during shipping. Inside the mold, every mold has the same basic components, starting here at the top with the crucible. This is where our weld metal is going to sit while the reaction is taking place. Moving down here to the disc seat, this is where our little disc is going to sit. Then we have our tap hole, which is going to connect our crucible to the weld cavity, which is where our conductors are going to be held in place while the connection is being made. Now, the graphite mold is soft. In fact, it'll wipe off in your hands. The average life of a mold is about 50 connections. That's totally dependent on how the mold is cared and how it's cleaned. You want to make sure that you use only a natural bristle brush or something soft to clean the mold. The whole point is to keep the mold openings the same size as the day the mold was purchased. As these openings get bigger, weld metal will start to leak out of the mold when the connection is being made. That's when it's time to get a new mold.
So using the same brush to clean the cable and the mold is not a good idea.
No, absolutely not. Two different cables, two different applications.
Right.
Okay, the next component in our system is the handle clamp. Now, each handle clamp, when it's purchased new from the factory, comes complete with a flint igniter. Talk about that in a second. Most molds that we sell, over 90% of them, use the L160 handle clamp, which is right here. Purpose of the clamp, again, is to keep the mold closed while the reaction is taking place. And you can see that it just goes in the openings in the mold, tighten down the thumb screws, and you can see that and get a nice lock on the handle clamp. Now, if the handle clamp is out of adjustment, if it's too loose or if it's too tight, there's an adjustment mechanism here on the handle clamp. You can adjust the throw of the clamp, either make it tighter or looser. The next component in our system is the weld metal. As you can see here, the part number comes on the box, in this case 200. And again, 200 stands for the number of grams of weld metal that's in the box. The shelf life of a box of weld metal is indefinite, provided that it's kept free from moisture and vibration. So let's open it up and see what we have in here. First thing that we'll notice is that each box of weld metal comes packaged with a required disc to make the connection. On the tube of weld metal, you can see that the part number is embossed on the cap. The 200 is again reflected. Now if we open the tube of weld metal, we're going to see there's a couple different components in here. The first main component, which makes up the bulk of the material, is copper oxide and aluminum. There's a little bit of tin in there and some other ingredients, but copper oxide and aluminum is the main component in the weld metal. There's no gunpowder, no magnesium, nothing like that. In fact, the ignition temperature of the weld metal is about 1750 degrees, so it's pretty safe. At the bottom of each tube of weld metal, it's kind of hard to see in here, but there's packed a fine gray substance called starting powder. If we knock that loose, you can see this is the starting powder. This is what we're going to use to ignite the reaction. Now the starting powder is made out of the same components as the weld metal itself. It's just ground into this finer form. That lowers the ignition temperature to about 850 degrees.
So nothing exotic, it's not gunpowder, it's powdered metal.
Nope, just powdered metal. That's all there is to it. As I mentioned before, each box of weld metal comes with a disc. And the disc is going to sit in our disc seat. And what's going to happen is after we put the weld metal in our crucible, we're going to ignite the weld metal, and it's going to start an exothermic chemical reaction. Exothermic is a fancy term that means it gives off heat. What's going to happen is that copper oxide and aluminum is going to separate into two components. It's going to turn into aluminum oxide, which is slag or the waste product of the reaction, and then it's also going to turn into superheated molten copper, about 4,500 degrees. I know what you're thinking, George, that's hot, but don't worry, it's a dry heat, like Las Vegas, so it's very comfortable. It's very important that before you make your first connection of the day, that you heat the mold up. Graphite is what we call a hygroscopic material, which means that it absorbs moisture from the atmosphere. And even though it doesn't look wet, there's actually a good deal of moisture in the mold. And our CADWELD connection gets up to about 4,500 degrees, and that's going to turn that moisture into steam. It's going to give us a bad connection.
Right.
So we're going to take our torch and dry it out. And you can actually see the moisture that's coming off the mold. It's very important that we get this moisture out. A lot of times you'll hear guys say that their first connection of the day looks bad and they have to redo it. It's because they're not drying their mold properly before that first connection.
So that moisture that's in the graphite ends up in our connection.
Exactly. There you go. Very important to dry the mold. It's a cold, wet day here in Cleveland. There was a lot of moisture in that mold that we needed to get out of there.
Right.
Now that our mold is dry, we want to double check to make sure that the conductors that we're welding are clean and dry as well. We're making a CADWELD connection that's basically permanent. It's never going to loosen, it's never going to corrode, it's never going to increase in resistance. Take an extra couple of minutes to make sure that everything is clean and dry. That way you won't have to worry about messing the connection up. So let's go ahead, put our conductors in the mold. All right, good. Our conductors are in the mold. Now what we're going to do is take our disc and we're going to drop it in the mold. You want to make sure that your disc is properly seated so it's completely covering the tap hole. We don't want any weld metal sneaking past the disc, otherwise we're going to get a bad connection.
Right.
Then we're going to take our weld metal dump it in the mold. We're going to knock our starting powder loose, and we're going to put about half of it on top of the weld metal, close the cover, and then the rest of it goes inside the cover opening. Now when you're done with a tube of weld metal, put it back into your weld metal box upside down. The way you know it's done, it also keeps the rest of the weld metal from jostling while you got it on the truck.
I noticed this is a different cover type compared to the standard mold cover. It's a little more sophisticated.
Yeah, not only is this cover going to contain the reaction a little bit better, but this opening in the mold cover is going to allow us to start the reaction a little bit easier if it's windy.
Right.
So now that we're all set, we've got our starting powder in the correct place, we're going to take our flint igniter and we're going to ignite the reaction. Okay? After the reaction starts, we're going to pull the flint igniter away and we'll be ready to roll.
Right.
That's all there is to it. After the reaction is done, you want to wait about 10 to 15 seconds to let everything solidify.
Right.
Now what happened there is that welding material, the copper oxide and aluminum, once we ignited it, started a chemical reaction, an exothermic chemical reaction, which is a fancy term which means it gives off heat. That copper oxide and aluminum turned into aluminum oxide, which is the slag product or the waste product of the reaction, and 4,500 degrees superheated copper. That molten copper melted through our disc, went down through our tap hole, and actually melted the conductors that are being held in place by the mold. Now that our connection is solidified, we actually have a completely welded connection. Let's open it up and see what we have.
Okay.
Now this material right here, this is the aluminum oxide. That's the slag product of the reaction I was just talking about. But here you can see our completed CADWELD connection. What we're looking for is a solid gold color on the weld. We don't want to see any pinholes, and we don't want to see a lot of slag included in the connection.
Right.
As long as you do everything correctly, you should never have a problem. In fact, this is restaurant quality right here.
Excellent. Well, that's a good looking connection, Chris.
Hey, thanks, George. Now, let's show everybody how to properly clean the mold. As I mentioned before, you're going to want to use a natural bristle brush or something soft to remove the slag in the mold. Now, we're not here to scrub the mold. We just want to gently brush it to get the remaining slag out of the mold.
And it's important that it is a natural bristle brush because nylon brushes melt.
If you properly take care of your mold, you'll be able to get more connections out of it, get a better use out of your mold.
Material comes off pretty easily.
Yep, just as simple as that. We're ready to make our next CADWELD